So for the first questions for this chem activity, one was the first PDF you guys got. Just looking at some of the questions here. We did talk about this in class, but so you have it for later. The essentials here's how many protons, neutrons, and electrons can you find in these various isotopes? And we have carbon-12 and carbon-13. Now, this is also carbon-13, but it is ionized. It's an ion. It has a negative notation right there. Still carbon-13. So if we scroll up here, we're going to see that carbon has 6 protons. And that is what makes it a carbon atom. It is the amount of protons. The amount of neutrons, however, can change. And hence you can see carbon-12, 6 plus 6, or carbon-13, 6 plus 7. And with the negative notation there, we have an ion, and you're going to see that you have 7 electrons instead of 6 electrons. Protons are positive and electrons are negative. And if we have one more electron than we have protons, we're going to have a negative notation here. So looking at the other questions, we have based on your answers, proton, what they have in common, carbon, what they have in common is they all have 6 protons, and hydrogen, they all have 1 proton. And so the atomic number, C, tells you how many protons that element have. And so you can go to the periodic table and find the answer for nickel, and the answer will be, of course, they all have the same amount of protons. And with the negative notation, that again, you have to compare how many protons compared to electrons you have. If you have more electrons, you're going to have a negative charge ion here. And if you have less electrons than protons, you're going to have a positive charge ion. And so we can look at the hydrogen here. We know that the total amount of particles in the nucleus is 1, and we know that is a proton because hydrogen have 1 proton. And that leaves 0 left for neutrons. And I know there's 0 electrons as well, since there is a plus sign there. So this is an ion that is positively charged. That means that the 1 electron it did have, it now has lost. And so the feature of isotopes are the amount of neutrons. Those are the ones you can change. They still have the same amount of protons. That's what makes them that specific element. But the amount of neutrons can vary. And that leaves the mass number A, which then tells you the amount of protons and neutrons together. And you're also going to see, if you go up here, you're going to see here, you have here 12, tells you it has 6 protons and 6 neutrons. But look at this, you also have an average mass right here. And that average mass here is this is the AMU, but you're going to have in these little squares in the periodic table, you can have an average mass, it says here. Now, this is a specific mass for carbon-13, but since we both have carbon-12 and carbon-13 in the natural world out there, the average mass of all carbons is actually not going to be 12. So just keep that in mind.